Hello everyone. So today we will talk about something interesting. There is an idea that the water drains differently in the northern and southern hemisphere. This controversy has been going on in our society for some time now, and the reason for this phenomenon has been pinned to what we call the Coriolis effect. So what is Coriolis effect? It is what makes things like planes or currents of air traveling long distances around the Earth to appear to move at a curve as opposed to a straight line. It is not a real force, but what we call an apparent force, because it all depends on your point of view and whether you're looking down from above or vice versa. It is a peculiar phenomenon, but the cause is very simple. It's because different parts of the Earth move at different speed. But how so? All parts of the Earth rotate around the axis at the same time. And how can speed vary in different parts of the Earth? Well, let's look at an example to understand this idea. So here we have the Earth in 2D, and there are two persons, red and gray. Red is closer to the North Pole, and gray is at the equator. If they start to go around the Earth, they would come back to their initial position at the same time. But gray is twice as far from the center than red, and gray has to travel more distance than red. We all know that anything that travels a greater distance in a shorter amount of time, it must be going faster. That means gray at the equator is moving faster than red. This proves our statement earlier that different parts of the Earth move at different speeds. Equator moves the fastest, and as you go towards the poles, the speed decreases. This change in speed can cause an object that travels above the ground to appear to move in a curved path and also to get deflected. Let's do an experiment to actually visualize what happens when something goes in a straight path.
Coriolis effect may sound complicated, but here I have a simple experiment to show how it works. So we have a chopping board and a disc of paper pinned to the chopping board, and we have a ruler and a pen. So now we're going to imagine that this disc of paper as Earth, and we have the North Pole on this side and the South Pole on the other side. And what we're going to do is we're going to draw a line from the South Pole to the North Pole while rotating the disc of paper anti-clockwise. And after, we're going to draw another line from the North Pole to the South Pole while rotating the disc of paper clockwise. So now we're going to do the experiment. So let's start the experiment. So now we're going to draw a line from the South Pole to the North Pole using a red marker while rotating it anti-clockwise. And now we're going to use the blue marker to draw a line from the North Pole to the South Pole while rotating it clockwise. So let's do that right now. So we're starting the north, rotating clockwise, and yeah. So we've completed the procedure, and let's move on to the conclusion. So the lines here actually represent the wind currents. So let's say a wind that is going to travel from north to south, it would deflect to the left. When the wind travels from south to north, it will deflect to the right. And also notice that we drew a straight line, but it looks curved here. This shows that Coriolis effect is in fact true. Any object that is not connected to the ground has a Coriolis effect on it, and that's what makes the object to move on a curved line when traveling around the Earth. So we'll talk more about Coriolis effect in the upcoming slides.
So let's continue more about the wind currents I was talking about in the video. So the Coriolis effect bends the direction of the wind currents depending on the hemisphere that the wind is in. And it is important to know that only the direction of the wind is influenced by the Coriolis effect, but not the speed. Wind speed are simply based on the pressure gradient of the atmosphere, and many other factors. Coriolis effect is the reason why low pressure systems and tropical storms rotate anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. Can you guess what hemisphere is this hurricane from? Well, if you think it is northern hemisphere, you guessed it right. So Coriolis effect not only impact wind currents, but also anything that flies. It can be a plane, bird, missile, space rocket, anything that flies. For example, a plane that is flying along a north-south path must not fly directly towards the target location. Instead, it must fly either slightly right or to the left of its location. So, Coriolis effect must be considered when determining the path of flights, and this plays an important role when launching missiles because accurate measurements are required when launching. So, this apparent force should also be considered. So, an interesting fact is that the Jupiter's red spot is caused by the Coriolis effect. Jupiter's large size and rapid rotation create a very large Coriolis effect in its atmosphere, and that's how the famous red spot is still unfazed to this day. So, Coriolis effect has impacted us in a lot more ways than we think, from weather patterns to transportations. And I thought this was an interesting phenomenon, and I hope you were fascinated by it too. So, thank you for paying attention. And if you have any questions, please ask me through my school email. So, I hope you enjoyed it, and thanks again.